Topic 3, Equilibrium in 3 Dimensions. Part 3, Examples continue. Hello students, welcome back. I am Dr. Sushanta Chakraborty, Associate Professor, Department of Civil Engineering, IIT Kharagpur. We are continuing with the examples on 3D equilibrium, and I have taken the reference of the book Engineering Mechanics Statics by Professor J.L. Merriam and Professor L.G. Craig. So this is the last and the fourth example, which is the body under consideration is supported slightly differently. So example 3.4, reference Merriam and Craig. Actually, it is exercise problem 3 by 78. Determine the magnitude of the force R and the couple M exerted by the nut and bolt on the loaded bracket at O to maintain equilibrium. So you may carefully examine, this is the bracket which is loaded by cables, and the arrangement is such it will provide only tensile forces, 1.6 kilonewton here and 2.4 kilonewton here, and this is secured completely by the bolt. So it is expected, if you now look back to the class notes of explanation for theory for the 3D equilibrium, this is a completely fixed joint, the reaction of which will be actually the force components in all three reference directional axes, and also the moments about all three reference directional axes. Solution. Step 1 is identify the body, which is the loaded bracket here. So this bracket is our body supported at O. Identify the forces and moments, both active and reactive, acting on the body. The fixed joint at O provides force and moment components as reactions, and the cables will apply active tensile forces only in the directions of the cable. So these two are the active forces, and here there will be reactive forces and moments. Now draw the free body diagram. So I have drawn this bracket with green color here, and then the cable force at 2.4 kilonewton at 30 degree with the y-axis, and 1.6 kilonewton 50 degree with this axis. And there are reactions happening at the point here, Rx, Ry, and Rz into the positive directions of the x, y, and z axis. And also the moments, reactive moments around the x-axis, around the y-axis, and around the z-axis. So these are the reactive moments. I think after attending the previous tutorial examples, this example will not be difficult at all, and I ask you to do it yourself. Just I want to bring to your attention the arrangement of the structure, which is somewhat looking complicated. So it has not directly told you that what kind of reaction will be actually happening here. So that is why you need to be careful about reading it and examining carefully that what can be happening to this joint. You see, if it is secured with nuts and bolts tightened, then definitely it cannot rotate, it cannot move, no translation, no rotation is possible. Definitely it is a fixed joint. And that is how you actually have 6 components of reactive forces and moments. How to solve this is very simple. We will write down the force equilibrium equations and also the moment equilibrium equations. And you can get one by one the force and the moment components at the supports. And also you can find out the magnitude, and also if you need with the components of the reactive forces, you can find out the unit vector into the direction and have the directional vector defined. Also, write it in vectorial forms. I have not done that, left it for you. You can also apply the moment equilibrium equations in statics, and then you can find out the moment components. Now, here, students, you might not be familiar about that a moment, reactive moment you have drawn there. So do not forget to include it into the moment equilibrium equation with proper sign. You have assumed a positive sign with respect to the right-handed system. That is why the moments mx, my, and mz are positive, and the other moments, depending upon the direction of the applied forces, the moment can be positive or negative. So you can find out the net magnitude of the moment, as well as, if you desire, you can find out the unit vector from the components, and you can express it as actually a vector. So if you want, you can have a total vector treatment of the whole of the problem. I have not done that. It's left out to you. You can have the position vectors of these forces here. You can have two position vectors, determine them and the unit vector into this direction, and write down the vectors directly, and you can have r cross f for the moments and account for in the moment equation. The same thing is done in statical components as well. So I think I have ended the lecture notes for the 3D equilibrium with two theoretical lectures. So one is explaining what you should do, the first lecture, very concentrate on that theory. You can find out the force and moment equilibrium equations, take care of the constraints, and that's it, nothing else. Just go ahead straightforward to write down the equilibrium equations. And in next four examples, gradually I have shown you different looking structures and different kind of constraints, as well as different application of the forces. All are to be framed into the same framework of 3D equilibrium, which cannot be solved by an assumption of 2D plane equilibrium equations. These are all 3D examples. Okay, thank you very much for listening all the videos.